NASA's James Webb Space Telescope may soon demystify the realm of Pluto and many other icy worlds. Since its launch in December 2021, JWST has sent back dazzling photos of distant exoplanets, intricate nebula nurseries, and galaxies whose light has taken over 13 billion years to reach our eyes. Soon, it will set its sights on the Kuiper belt, a massive disk just beyond Neptune's orbit that's home to comets, asteroids, and other icy bodies. And among these bodies is Pluto. The worlds and objects beyond Neptune are largely unexplored territory, Pluto included. But work has begun on using JWST to uncover them. Maybe we can learn a few more details about the dwarf planet that sits on the edge of the solar system. Pluto is far. It takes sunlight 5.5 hours just to get there. And when it comes to completing one rotation around the sun, it takes a whopping 248 years. Its orbit crosses the orbit of Neptune, but surprisingly, never collides with it. It takes about 6 Earth days for one rotation around its axis, and the axis itself is tilted by about 120 degrees, making Pluto revolve almost around its side. Pluto's orbit around the sun is unusually different from the other planets. It's both elliptical and tilted. Also, being around 1,200 kilometers in diameter, Pluto is also about the size of the United States. We have the word planet that we inherited from the past. It meant a celestial body of a long time, but as we gain more information over time, that information told us that the previous definition didn't suit the greater factors within the old definition. The more you know, and the more precisely you must measure, you either need to invent a whole new word or try to refine the definition of the old word. Since we couldn't redefine the word planet, because that would cause massive upheaval in the realm of scientific literature, we chose instead to create a new classification. So what is a planet then? Is Jupiter or Ceres or Titan a planet? In a pre-scientific age, it didn't matter. But in a scientific age where we see bodies we know of as planets, we see that they tend to do certain things. They orbit their host star, clear their orbital path of rubble, and have enough gravitational pull to overcome the rigid protrusions of rock to round out the surface. Mars, Earth, and Saturn all do that. Gravity has rounded out their rough edges. So if we have a planet that doesn't match these characteristics, then what do? We either expand the definition of planet or remove the previous object we called a planet from the list. Ceres and Pluto are different sizes, but size only matters insofar as the body can generate enough gravity to round out the surface, which both does. Both bodies orbit the sun. Neither of the two bodies have sufficient gravity to clear their paths of debris, which means we have a problem. Do we call them both planets, or do we adjust who gets called a planet? Calling them both planets would disturb the established nomenclature of what we define to be a planet. So, instead, as of 2006, we revoked Pluto's planetship and have given it the status of a dwarf planet. Initially, there was no thought of any moons orbiting Pluto until 1978, when U.S. Naval Observatory astronomer James W. Christie noticed something unusual while making routine measurements. He noticed that a number of the images of Pluto appeared elongated, but images of background stars on the same plate did not. The images show that Pluto and Charon orbit their common center of mass and are locked in a super synchronous rotation. This essentially means that observers on Pluto's surface would always see Charon in the same part of the sky relative to their local horizon. So technically, as this is not so much a moon as a twin planet, as Charon and Pluto orbit around a point outside Pluto. This animated GIF shows Pluto and Charon. The Hubble telescope managed to image additional moons in 2005 by astronomers of the Pluto Companion Search Team preparing for the New Horizons mission in 2006. The new moons were called Nix and Hydra. The moon Kerberos was announced on July 20th, 2011, being discovered in a search of Plutonian ring system, Styx. Announced on July 7, 2012, was discovered while looking for a potential hazard of the New Horizons mission that flew through the system in July 2015. So in total, Pluto has 5 moons, though Charon is the most massive, while the others are far smaller, irregularly shaped moons and are much fainter. NASA's New Horizons mission is the first probe to study Pluto, its moons, and other worlds within the Kuiper belt up close. It flew past a distant dwarf planet and its moons and took a large number of pictures and various instrument readings, and then sent them back over the next several months, making it the first craft to ever do so. The limited knowledge of the Pluto system created unprecedented dangers for the New Horizons probe. Prior to the mission's launch, scientists knew the existence of only 3 moons around Pluto. The discovery, the Kuiper, and Styx during the spacecraft's journey fueled the idea that more satellites could orbit the dwarf planet unseen from Earth. Collisions with unseen moons or even smaller bits of debris could have seriously damaged the spacecraft. But the New Horizons design team equipped the space probe with tools to protect it during its journey. And luckily, in October 2021, New Horizons made history when it returned this image. It shows Pluto surrounded by the light being reflected off of Charon. Now that is a lot of light reaching the distant recesses of the solar system. So how big would the sun look if we were sitting on Pluto? Well, according to Ron Miller, it would look like this. To put that into perspective, the sun would still appear 250 times brighter than a full moon on Earth. The giant mass overlooking the dwarf planet is the moon, Charon. And just a bit of trivia. If our solar system was scaled down so the sun was 1 meter in diameter, Pluto would be 4.2 kilometers away and a mere 1.7 millimeters in diameter. One thing that New Horizons allowed us to do was understand the chemical composition of the dwarf planet. Since Pluto sits on the distant edges of the solar system, the temperatures there are frigid, reaching negative 370 degrees Fahrenheit at their lowest. By analyzing the distant wavelengths of light reflecting off of the planet's surface, we know that it is made up of nitron, carbon monoxide, and methane. By owing to the low temperatures, all these substances exist as solid. When sunlight strikes part of the surface, it causes nitrogen to convert directly to a vapor through a process called sublimation. Pluto's tenuous atmosphere of nitrogen, methane, and carbon dioxide is about 100,000 times thinner than Earth's atmosphere, but it has about 20 regularly spaced layers of haze extending up to 150 kilometers above the surface. It is believed that these layers are created by the mountains on Pluto's surface. By interrupting the airflow in the winds of Pluto, the air is separated into multiple layers. Nearly all Pluto was mapped by New Horizons in July 2015. The cameras were turned on to Pluto several days before its closest approach, and since it has a rotation period of about 6 Earth days and 9 hours, New Horizons was able to map the entire surface of the dwarf planet with the exception of a very small region of the extreme northern hemisphere, which was in darkness due to Pluto's extreme axial tilt of almost 120 degrees. In actuality, maps of Pluto have existed since 2003. In the 2002 to 2003 timeframe, the Hubble Space Telescope was pointed at Pluto and managed to resolve large surface features at a very low resolution. Before New Horizons, this was the best image of Pluto that we had. But with New Horizons, you get a far more detailed image and can even make out Thurmbo Regio, the largest bright surface feature of the dwarf planet. In addition to mapping Pluto, New Horizons was able to map Charon, which was totally out of Hubble's capabilities. But just knowing that if scientists are making these breakthroughs with the advent of modern technology, there is probably still a lot we might not know about the planets in our own solar system, and Pluto is certainly a testament to how much we have yet to uncover. Maybe pointing the JWST to Kuiper will tell us more about our neighboring dwarf planet. So there you are, guys. I hope this video offers some good insight. If you enjoyed it, be sure to hit that like button and subscribe for more content like this. And as always, thanks for watching.